let's take a look at some of the graphing and the word problems from section 4.2, starting off with question number 6. Now for this problem, I have gone ahead and I have labeled my graph here, and I've also set up a table of values on the right hand side. And now let's go through the problem here. So I need to draw a graph to describe the income of a car salesperson who earns $600 per month plus $250 for every car sold. Okay, so if I sell 0 cars, and if I just come into work, I am paid $600 for the month. Okay, if I come to work and if I sell 1 car, I may earn my $600 plus I earn another $250 because I sold 1 car, right? So that's your amount that you make for commissions. So 600 plus 250 is going to be $850 if I sell 1 car. If I sell 2 cars, then I just add another $250 to $850. So $850 plus $250, that's going to be $1,100 if I sell 2 cars. If I sell 3 cars, I just add another $250 to $1,100, and that gives me $1,300 or $1,350. And then finally, let's just do 1 more car, and if I add another $250 here, I make a total of $1,600 for the month. All right, so after that, what we're going to do is we're going to plot the points here. So if I sell 0 cars, I have an income of $600. So this is your y-intercept. So roughly that's going to be this point over here. All right, so do your best to sketch the point 0, 600. Then after that, we're going to do our best to sketch the rest of the points. So the next point is 1, 850. So 1, 850, do your best to sketch that. So maybe around there. So that's 1, 850. And then let's do the next one here, 2, 1100. So after 2 cars, that's going to be about $1,100. So maybe around here based on my graph. So there's 2, 1100 around there. Actually, no, it should be a little bit higher. Should be about right in the right about there. Okay. Oops. Okay, so that's the point 2, 1100 right there. Okay, and then after that, let's do the rest here. 3, 1350 is the next point, which is this point right here. Okay, so at 3 cars, we have 1350. So 1350 is about there. And finally, 4, 1600. This is one of my nicer points here. So 4, 1600 is about there. So there's a sample graph of there's a sample graph of the points I've used. I've only went up to 4 cars. I mean, you can definitely sell more cars than that, but this is roughly a graph of the data that I've used for my problem here. So up to 4 cars. Okay, let's move on to question number 7 here. And for question number 7, yes, I have gone ahead and I have kind of labeled my graph here, and I also have a table of values on the right hand side. Let's go ahead and read this problem and let's see if we can figure it out. I need to draw a graph to describe a jet whose altitude climbs from sea level to 9,600 meters at a rate of 1,600 meters per meter. Or sorry, at a rate of 1,600 meters per minute. Then we cruise at a steady altitude for 5 minutes, and then we descend back to sea level at a rate of 800 meters per minute. Okay, so quite a bit going on in this problem here. So let's go ahead and break this down step by step. All right, so we start off at sea level. So for sea level, that's basically a height of 0, and that's going to be at the very beginning. So this is basically sea level. So sea level basically once again means we have a height of 0. Now, although we do reach a height of 9,600 meters, we are actually going up at a rate of 1,600 meters per minute. All right, so what does that mean? What that means is every minute we're going up by 1,600 minutes until we reach 9,600 meters. So after 1 minute, then we reach a height of 1,600 meters. All right, so we're going up by 1,600 meters. Right? Then after 2 minutes, what height are we at? Well, since we're going up by 1,600 meters, after 2 minutes, we are at 3,200 meters. Then after 3 minutes, we are at 4,800 meters. 4,800 meters. So we're just adding 1,600 meters every minute. So after 4 minutes, if I continue this pattern here, we'll be at 6,400 meters. After 5 minutes, we're going to be at 8,000 meters. And then after 6 minutes, we finally reach 9,600 meters, right? So from 8,000 to 9,600, we just add 1,600 meters. Okay, so after 6 minutes, we finally reached this height of 9,600 meters. Okay, so at 6 minutes, we're at 9,600 meters. So if I plot that point, it's going to be around here roughly. So this point is roughly there, right? And then if I also plot the y-intercept, it's 0, 0, right? So that's going to be right at the beginning here. So this point is going to be right over there, right? So let's plot those 2 points first on our graph. And then from there, let's go ahead and connect this graph here. So I will use a orange marker here. So basically, this is my line right here. That's connecting the 2 points. Okay, so that's the first part of the problem from 0 to 6 minutes. Okay, now what I'm going to do next here is I'm just going to create some space here. So I'm going to erase all this, and I will continue my table from... I'm just going to transfer this point over to the top now because I need a little bit more space. Okay, so let's start off at 6 minutes. All right, let's go back to the problem now. Then if I read the problem here, it says, then we cruise at a steady altitude for 5 minutes. Okay, so for the next 5 minutes, we are cruising at the same altitude, all right? So for the next 5 minutes, so 7, here's 7, that's right, here's 7, 8, 9, 10, 11. Now, if you see this, this is really your 5 minutes, right? So for the next 5 minutes, we are at a steady altitude, right? So steady means that we are not changing the height, so we remain at 9,600 meters. Sorry, I'm having a hard time writing out that number here, so we're staying at 9,600 meters. So let's fill all those points in, okay? All right, so let's go ahead and transfer those points onto the graph here. So 11 minutes is the last one here, right? So where's 11 minutes is about, 11 minutes might be about here, so maybe we'll put a dot right there. Sorry, maybe we'll put a dot somewhere around here. Okay, and then, so basically this point right, this point right here, 11 comma 9,600 is roughly that point right there. So I'm going to have a horizontal line connecting these 2 points right there, right? So that's a steady altitude. Steady altitude means you have a 0 slope. You're not changing. So that represents the next 5 minutes there. Okay, so what I'll do next is I'll erase this part now, and I will put the 11 minutes and 9,600 meters at the very top now to continue the rest of my problem here. I believe we are now on the third phase of this problem now. And now the question says, then we go back. Descends means we are now, our height is now decreasing back to sea level at a rate of 800 meters per minute. Okay, so now we're going back down to a height of 0 at 800 meters per minute. Okay, so what does that really mean, this 800 meters per minute? So my next minute is going to be the 12th minute. At 12 minutes, I will go down 800 meters, right? So I'm going down 800 meters. So when we're at 12 minutes, we are now at a height of 8,800 meters. And at 13 minutes, we take another, we lose another 800 meters. So now I'm at 8,000, or yeah, 8,000. And then at 14, we lose another 800 meters, so now we're at 7,200. And at 15 minutes, we're going to lose another 800 meters, so now we're at 6,400 meters. And we keep on going, and if you continue this pattern, it's actually at 23 minutes, we get down to a height of 0, right? So that's how we would kind of finish off this problem here. Now, although I have a table here, there are some quicker ways to get down to 23 minutes at a height of 0. If you can divide the numbers correctly, you can get down to 23 minutes correctly. So ask in class if you want to know how to do that very quickly. So 23 minutes is about here. So hold on, get my green marker here. So 23 minutes is about right here. So we go straight down to 0, 23 here. Okay, so that's this point right there, roughly. So after 23 minutes, we go back to a height of 0, which is the sea level there. All right, so that's a sample answer for that particular problem. And make sure you do label your graph correctly and follow the storyline there. So there's 3 different parts to this particular problem here. Okay, let's move on and let's try a few more of these word problems. So the next question we're going to try is question number 10 here. So once again, I do have a table set up there. A plane at an altitude of 20,000 feet. So we're above the air, above the ground 20,000 feet. And we start to go down for landing after flying for 6 hours. Okay, so after 6 hours, maybe we are up in the air 20,000 feet. Okay, and the entire flight time was 6 hours and 40 minutes. Okay, so when we're at 6 hours and 40 minutes, we go back to a height of 0, right? Because the entire flight was 6 hours and 40 minutes. So after 40 minutes, from 6 hours to 6 hours and 40 minutes, after 40 minutes, we reach a height of 0 because we're back at the ground. All right, I want to determine the average rate of descent of the plane. All right, so how fast are we falling to the ground? All right, so the average rate is the same thing as the slope. And slope is really from 4.1. You can use the rise over run, which is a difference in the y values divided by a difference in the x values. And now the question is, what's the value of y2? Well, y2 is going to be 0. All right, and then what's the value of y1? Well, y1 has a value of, I guess a y1 will have a value of 20,000 here. So 0 minus 20,000, all divided by x2. Now, what's the value of x2 here? X2 is going to be this number right here. So 6 hours and 40 minutes. So 6 hours, I'll say 6.40. And then minus the x1 value, which is essentially going to be 6 there, right? Now, if you think about the denominator, the difference between 6 hours and 40 minutes and 6 hours is really just 40 minutes, right? It's really just 40 minutes there, even though I may have not written the units out here correctly. Remember, we started off by being 6 hours up into the air, and then after 6 hours and 40 minutes, so this difference between the starting point and end point is just 40 minutes, which represents that number right there. And then if you do a 0 minus 20,000, you get negative 20,000 here. Okay. And if you do this calculation on a calculator here, you get negative 500. So we're going down 500 feet per minute. All right, so remember how we get the feet. Feet is really your y value divided by your x value, right? So feet per minute. All right, and that's the average rate of change for that problem there. Okay, let's do question number 11 here. I'll do question number 11 in a similar manner to question number 10. I have a table of values set up over here, and let's read the problem here. As a window washer begins work on a high-rise, 1/3 of the windows were already clean. 8 hours later, 3/4 of all the windows are clean. Calculate the windows washer's cleaning rate. Okay, so the cleaning rate is the same thing as find the slope. Okay, so let's figure this out. At the beginning, so we haven't spent any time washing any windows. So at the beginning, at 0 hours here, the question says 1/3 of the windows are already clean. So let's put 1/3 over here. So 1/3 of the windows are already clean. All right, so 8 hours later, so from 8 hours, so I go from 0 to 8, right? So 8 hours later, it says 3/4 of the windows are all done. 3/4 of the windows are all done. Okay. I want to calculate the window washer's cleaning rate, which is the same thing as finding the slope. So just like question number 10, slope is really a rise over run, which is a difference in your y values divided by a difference in your x values. Okay, so what's the y2 value? Just like in the previous problem, it's going to be 3/4. All right, so 3 over 4 minus, well, what's y1? Well, y1 is 1/3. So minus 1/3. And then what's the value of x2? Well, the value of x2 is going to be 8. And the value of x1 is going to be 0. So 8 minus 0 in the denominator there. All right, so now we need to figure out this calculation, and then we've got it. Well, the denominator is a little bit easier because 8 minus 0 is going to be 8 minus 0 is just going to be 8. Now, this fraction, the 3/4 minus the 1/3, I mean, I'll just do that calculation on the bottom here. There's a number of ways you can subtract fractions, I kind of use the crisscross happy face method. So 3 times 3 is going to be 9. 4 times 1 is going to be 4, so minus 4. All divided by 3 times 12, which is, 3 times 4, which is 12. So I get 7 over, 9 minus 4 is 5, so I get 5 over 12 here. So this will be 5 over 12. Okay, and then just to kind of finish up here, how do I finish off this calculation? Well, this is the same thing as 5 over 12 divided by 8. Now I can divide it by 8 over 1. And now this is the same thing as 5 over 12 times, and then I can flip this fraction, times 1 over 8, which is 5 over 96. And this is units are of all windows. Of all windows per hour. All right, so 5 over 96 will be the window washer's cleaning rate. Okay, so that's it for number 11, and we'll finish off this homework video with question number 15 here. So 15, there's a little bit of work to do with this question here, so let's try to do this question very slowly. A water tower holds 10,000 liters of water. When a valve is open, the tower has 9,700 liters after 30 seconds. Okay, so in the beginning, so the way we illustrate beginning is a time of 0. We have 10,000 liters of water. Okay. Now, when the valve is open, the tower has 9,700 liters after 30 seconds. Okay, so after 30 seconds, we're going to let some water go. And then once the water is leaving the tank and we shut the tank after 30 seconds, we have 9,700 liters left. Okay. And then we also have 9,400 liters after 60 seconds. So after 60 seconds, there's 9,400 liters of water left. Okay, so the question is, the first question is, the question states that the water continues to drain at the same rate until the tower is empty, okay? Now for part A, I need to determine the rate of change of the volume with respect to time. So what is the rate of change of volume, right? So how fast is the water leaving the tank? So this is the same thing as finding the slope, right? Anytime you're going to find a rate of change, that's the same thing as finding the slope. So just like the previous two questions, slope is rise over run, which is a difference in your y values divided by a difference in your x values. All right, so what is y2 here? Well, for y2, let me just use the 9,700 here. So that'll be 9,700 minus y1. The y1 value I can use now is the 10,000 there. So minus 10,000, all divided by, now the x2 value that I'll be using here, the x2 value here is going to be 30. So 30 minus, and then what is the x1 value here? Well, that's going to be the 0 value here. So 30 minus 0. Okay, so let's go ahead and calculate this. So 97,000 or 9,700 minus 10,000 is going to be negative 300 on the numerator, and 30 minus 0 is going to be 30, right? So negative 300 divided by 30 is going to be negative 10 liters per second. Okay, so that's all the work that you have to do for question 15A. All right, so let me just erase some of this. And let me just write the answer here as negative 10 liters per second. That's my answer there for part A. Okay, now let's move on to part B. How much water remains after 4 minutes? Okay, so 4 minutes, basically, let's convert that into seconds. So if you do 4 times 60, that's going to give you 240 seconds. Okay, so the question is, how much water remains after 4 minutes? Okay, the reason why I want to change 4 minutes into seconds is because based on our rate of change here for part A, we are losing 10 liters per second, right? So this is our rate of change, negative 10 liters per second. Okay, we are losing 10 liters per second, right? We're losing 10 liters per second. So if I'm losing 10 liters per second, and the valve is open for 240 seconds, all right? And if I multiply these two numbers together, I get 2,400 liters. And since there's a minus sign, I'll put a minus sign there saying that after 4 minutes, we've lost 2,400 liters, right? We've lost that much of water. But the question is, how much water remains, right? So at the beginning, we had 10,000 liters, right? At the beginning, we had 10,000 liters, but after 240 seconds, which is 4 minutes, we actually lose 2,400 liters, right? So we're losing 2,400 liters, and that gives us a grand total of 7,600 liters. Okay, so that's how much amount of water remains after 4 minutes, because every second, we're losing 10 liters, right? So after 4 minutes, which is 240 seconds, we will lose 2,400 liters, which means that there's 7,600 liters left. Okay, so hopefully that kind of made some sense. If it didn't, please see me in class. Let's move on to question C now. How much time is needed to empty 3/4 of the water in the tower? Okay, so how much time is needed to empty 3/4 of the water in the tower? Okay, so if we want to get rid of 3/4 of the amount of water in the tower, we're really taking 3/4 of the original amount, which is 3/4 times 10,000, and that gives us 7,500 liters. Okay, so the question is, how much liters do we have? We have 7,500 liters, and the question is, how much time will that take? All right, so how much time will it take for the amount of water to get down to 7,500 liters, and that represents 3/4 of the amount of water in the tower. Okay, well, let's think about this logically. Back in part A, we know that the rate of change is 10 liters per second, right? So every second we're losing 10 liters. Okay, so if we're losing 10 liters per second, if I take a look at this 10 value, right? So 10 liters per second times by how many seconds gives me 7,500 liters. That's the math problem that you're essentially solving, right? So if you're losing 10 liters per second, how many seconds do you need to get to 7,500 liters? Now this math equation is essentially the same thing as solving this. 10x equals to 7,500. All right, this math problem is the same thing as solving that math problem. So let's divide both sides by 10. So x equals to about 750 seconds. Okay, and hopefully that makes sense, right? If you lose 10 liters per second, and if you are losing water for 750 seconds, I mean, if you multiply those two numbers, 10 and 750, those units cancel off and you get 7,500 liters. Okay, so hopefully that makes sense there. So after 750 seconds, we get down to 7,500 liters. Although now the back of the book won't have the answer as 750 seconds. So if you want to change this to minutes, you can divide this by 60 because there's 60 seconds in 1 minute, and that gives you 12.5. So what this really means is there's 12 minutes, and this 0.5 really means there's 30 seconds, right? So half of a minute is 30 seconds. So 12 minutes and 30 seconds for that problem. Okay, final problem, question D here. Let me just kind of erase all this and create some space here. How long does it take to empty the water tower? Okay, so very similar to question C, we want to have 0 liters, right? So we're definitely losing 10 liters per second, right? So the question is, if you're losing 10 liters per second, how many seconds do you need to lose 10,000 liters, right? So there's 10,000 liters in the tank and we're losing 10 liters per second. Let me write this as 10 liters per second here. And how many seconds do we need to get to 10,000 liters? Because 10,000 liters is in the tank. So this is the same thing as solving this math problem. 10x equals to 10,000. And then you can divide both sides by 10. And then x would equal to, if we do the math here, I guess x would equal to 1,000 here, so 1,000 seconds. So it takes 1,000 seconds to lose 10,000 liters. And think about if that actually makes sense here, right? If you're losing 10 liters per second and you turn on the valves for 1,000 seconds, 10 times 1,000 would give you 10,000 liters, right? So literally it takes 10,000 seconds for you to lose 10,000 liters if you're losing 10 liters per second. Okay. Now, once again, the back of the book probably won't have 10,000 seconds, so if you divide this by 60, you can change this into minutes. And let's see if I can do this on my calculator. So 1,000 divided by 60 is going to be 16 minutes. It's going to be 16.666, and this is roughly 16 minutes. And this is like 2/3 of a minute, so that's going to be 40 seconds. Okay. So hopefully this part makes sense here. The 0.66 is 40 seconds because 0.66 is really 2/3 as a fraction, and 2/3 of an hour, I mean there's 20 minutes, 20 minutes, and 20 minutes, right? So 2/3 would be 40 minutes, 40 out of 60, right? So it would be 40 seconds there. Okay, so I was kind of going a bit fast with some of the word problems there, so if you have any questions, please speak to me in class.